I got my spindle motor kit in, and this is, like many others, is a Huanyang spindle motor and converter. And I bought my kit from Amazon from a seller called My Sweetie, and no, I'm not being compensated for this from any way, at least not now anyhow. So this is what I chose. And anyway, so what can I say about the kit? So the motor itself seems pretty beefy, and it's, you know, like 80 millimeters long, and I think this is by 200. I think this is roughly 200 millimeters long. The motor I bought has an ER20 collet in it. You could see it there. And I think the motor itself may come with 2 collets and a little, it's kind of like a microphone plug, a 4-pin DIN plug, like a microphone plug. It's fairly heavy duty, but still, you know, on the edge of what you would want to use for something like this. This is only 8.5 amps. I think that'll be okay. It's not quite military style connectors. The clamp is machined only on these 2 surfaces and, well, in the slot. The clamp is configured so that this bolt here actually opens up the clamp while these close it, so you can take this bolt out and save a little weight after you're done installing it. The machining on the spindle motor, at least on the outside, seems really nice. There's some balancing marks here. You can see where they dynamically balance this and drilled it out in a few places. I worry about losing a nut like this or having it, God forbid, strip out or something like that. There's actually a little gap right here, and I don't know why in its construction, but there's a little gap right here. Perhaps this collar pushes pressure to set the bearings or something like that. I hope that's not an issue with my motor. There's no perceivable play or anything. I didn't put an indicator on it or anything at that point, but it's not clicking in the inside the housing anyhow. So the VFD is actually made a little bit better than I thought it would be. This kind of membrane key switch stuff also covers the display, which is kind of, you know, not so good. But I like that this one does have a speed control for those people who are not going to hook up theirs, or for those people who are just going to leave it steady and use the on-off kind of routine, whether it's manual through here or manual through or semi-automatic, more or less, through the 3 speed settings you can choose from the VFD. You know, the switches are clicky, and as far as these, I don't mind these being clicky. But I wish these were real switches for on and off, because some people might want to choose to run this, you know, just in a manual sense. Looking over the VFD, there is a void of removed seal, but it's not in English, so nothing can, you know, that's not going to stand in the American courts. You have some, you know, some more labeling here. These things haven't been slit yet. You've got to do that. You can see the capacitor is through here, and the heat sinks through the little fan opening. What they say about the back of this, that this hasn't been, this is not exactly flat, and I think they're pulling these out of the molds too quick. And then what I think I'm going to do is just put some washers in here. And the kits also came with some extra collets. You've got collets ranging from 1 millimeter to 13 millimeters. I don't know why you need a 1 millimeter collet. I've even circuit board drills would use something bigger than a 1 millimeter collet. I think if you're doing jewelry, this might be okay, but this is a rather strange inclusion. And oddly, there's no 12 millimeter collet in this set, but there is a 1/2 inch, and this could actually be this relabeled. There's also a 1/8 inch collet, which is nice for, you know, if this kit's being sold in America for a 110 volt kit, then you know, having a 1/8 and a 1/2 inch collet is a good idea. Rather than see a 1 millimeter collet, I would like to see maybe a 1/4 inch collet, so you can use die grinder tools and stuff like that. And maybe one of these others would do it. Hypothetically, this should fit anything within this range, except for, once again, there's no 12 millimeter, but maybe that's a 12 millimeter remarked. So the kit came with hose, and I think this is like 15 feet, and if that's true, then it's about half as much as I need. And so I'm going to have to go out and source some and find some hose. And I believe this is nylon tubing, like you would have an oil, like for an oil pressure sender on a car or something. And unfortunately, I think this is going to be too tough for my application. I don't think this is going to play well in the cable chain, so I'm going to opt for something softer, but I have to make sure it doesn't kink. The kit also came with this submersible aquarium pump with little suction cups on the bottom, and you can regulate it. I don't know why you'd want to regulate it for a CNC machine, because it'll regulate itself. It also came with three adapters, and I don't know if these are the same size as a hose, but it comes with 3 adapters. None of these adapters are appropriate for the hose, and so I'll have to get another adapter. I really wish that they took these and not made them, and just include the right one, because not so much that I've got to go out and buy the right thing, and well, that's part of it, but also, what am I going to do with these? What really am I going to do with these? And so these are going to end up going in the trash or something at some point. Maybe I'll make some kind of piece of art out of them or something. But I like that there's a pump, and I wish there was an adapter. The kit also came with this. This is actually, it's like a linear brush thing. It's all rolled up now. And you can wrap this around like a vacuum attachment, so you can pull chips away if you're just doing wood. I think for a lot of people, this is a good inclusion on the kit. This is a really good inclusion, I think. A lot of people like this. And they might not know what it's for at first, but once they start vacuuming up stuff, this will make sense. So this is a good addition. This was not a good addition for the kit. These are insanely pointy drill bits, a very, very small size. And as far as I know, they're not engraving bits. Maybe they could be, in a pinch, they could be used for engraving. And I don't know why they included so many in the kit. If I was for Americans, if I was doing a kit, I would include maybe 1 or 2 of these. And I would include a 1/4-inch milling bit. Actually, I would include 2 1/4-inch milling bits, so after they break one, they don't have to go to the store too quickly. Yeah, so overall, that's the kit, and so far, so good. And the motor does seem impressively stout, you know, and if you get this size motor, you have to understand that this thing is heavy, and this thing is heavy for almost any Z-axis would feel the weight of this, and so it has to be one of your considerations of whether or not your machine is strong enough to hold this thing. And my machine is strong enough to hold this, but I worry about that the motor actually sticks out a little bit too. You know, it's like I don't want to drop it, but you can see I'm an extra 1/2 inch out, and it's because of this plate. And if this were an air-cooled motor, I should think that this clamp, it would be a good idea to sand it on the bottom and put some heatsink compound on the bottom. But it being water-cooled, I don't think it'll make much difference. So that's the kit. I thought to put a little Hello Kitty thing on here. Anyway, I've got, this is a Z-axis, and I have the spindle motor just kind of, and it's clamped on lightly. I put a little plastic cap on the end of the spindle motor, so if I drop it, it won't damage the spindle. There's like a 1/4 inch of space there. And I still don't want to drop it, but this lets me also rest it gently on the end, which was the force transmitted into this little collar, which actually probably adjusts the bearing, so I still don't want to drop it. Anyway, so I have this clamped on with right now a single clamp. And I have some blocks and stuff to hold it up. So we're looking at the side now, and once again I have this propped up. I've got a little plastic cup here protecting the end of the spindle motor. And so, other than protecting it, allows me to just gently rest it so I can prop it up, so I can clamp it. This is a little woodworking clamp here. I have a 1/2 inch milling bit here, and it's not necessarily a router bit, but it's a milling bit. And this is about level with the, as if you put it in, you know, as far as the tool grip, it's about level with the, how it would be if it was in a spindle motor. Unfortunately, I'm not happy with the height here, and so what I want this thing to do is go up higher. And one thing I can do is I've got a gap here, and I could bring this up by 20 millimeters, and so that'll move the whole Z-axis up. Here's the linear way blocks here, and here's the linear way, and it still has some stick out here at the bottom, so I can move the limit switches up maybe another 15 or 20 millimeters. So that'll help too. I'll get 40 millimeters, and if I look at this, if I look at 40 millimeters, that's about all I need for this. And if I use drill bits, I'll have to use, you know, shorter drill bits. And perhaps also I can adjust the motor up or down. And in the final configuration, maybe the clamp should go down. I'm still looking at this. But one thing that's also an issue is the distance from here to here. And so this makes a lever arm like this. So this pulls on this. This is not good. And I'm out pretty far right now. To the center of the spindle motor, I'm out like 22 centimeters. And I'm not so worried about this right here. I'm not worried about these rails really at all. These are really tough rails. There's a thing called the center of moments or the center of rotation, basically. When this thing is milling, it will want to put upward pressure rotating this thing up like this. And that will put upward pressure on this bearing and downward pressure on this bearing on the gantry. And those are the bearings I'm really worried about. These I can probably find something for. And these things are very excessive. These are double row. The other ones are not. And likewise, when you're not milling, the motor will want to sag like this, and it'll put downward pressure on the front bearing and upward pressure on the backward bearing. And if the farther away this thing is out, the more chances are that this thing will jostle like this or jiggle like this, because there might be a little tolerance in the bearings and stuff. They might not actually be compressed. Some of these bearings in the gantry, you can order them so they're an interference fit. So they're actually sprung in there, but I'm not so sure that that's the case with these. So I want to bring this thing in at least a ½ inch for now. And in order to do that, I'm going to have to trim these blocks. We're looking at this is the top of the Z-axis, this is the bottom, this is where the motor would go. Originally these parts were arranged like this, and you can see how much wasted height there is here. Like I said, I'm tired of reworking this thing. I'm just going to do it once and get it over with. So what I decided to do is I'm going to flip these like this. And these surfaces are milled, and they're probably flatter than I can get it. And it comes down so far that I really have to turn this thing on its side to make it work. And I'll probably have to shim it between here and this top plate. And so what do I have to do? I've got to drill and tap holes into these, and I don't have a lot of material to do that. And I've already marked. I took a marker and I scribed around these because I no longer have any accurate reference marks, because this is just sanded. This was machined. This is sanded. So anyway, so I think that's what I'm going to do. And I have to make a shim or something to attach this to this plate. And the really hard thing is that you see these blocks here. These have to be lower by quite a bit. Or maybe when I get then I'm going to have to just maybe it'd be easier just to replace these with a piece of flat stock. So I'll have to look at this a little more, but that's generally what I'm going to do. Also, I was looking at this ball screw, trying to figure out, is it the same height here and here? If I measured that diameter into the surface, that doesn't mean anything, because this bearing hole could be bigger than this bearing hole. This is probably an angular contact bearing. This probably is not. So I took a little one of these little bore gauges, and I got it so it might be off a little bit, but I got it so it's just snug here. And it's just snug here, and it's so close that I can shim it the rest of the way. So I'm going to do this once more and get it right and be done with it. What will all this work get me? It looks like it'll get me at least 30 millimeters, and that's a lot. So this thing's going to be slammed lower in the ruckus. And so also what I'm concerned about, and what I'm checking here, is that these blocks have to be cut down. Probably this top surface has to be cut down like this, so this will fit under here. And also I've got things fitted to the side of these blocks, and I'm going to have to rework that, and as well as the switches. So I'm looking at what I have to cut. I've got to trim this so the motor will clear, and the associated motor mount will clear. I want to trim this, make it a little bit lighter still. It's not much, but times 2 it's something. I've got to trim these things off, and 2 of these, and get these the same height. I'm not sure if I'm gonna. I'm worried that there's not enough material on this side, so I'm gonna go in through this side. So I got to put 2 holes to fix this from the bottom, and I'm worried because there's not enough material here for me to feel comfortable. So I'm gonna go through the laborious thing of I'm going to trim this. After I trim this, I'm going to make this the same height, and these have to be the same. It doesn't really matter what size these are as far as this dimension, as long as these both are the same. And I got to trim these little bosses off of here, and this is the ball screw mount, and this is just for location because I've taken off almost every, there's only one original edge left on this thing. It's this far edge here, which you probably can't see. So this doesn't have to be cut. This is just for reference because I've cut on every edge of this except for this one. So I only have one reference edge left. I can't. I should make a milling machine. I have 3 parts to trim, and I'm going to trim them mostly the same way. I've got a little vise here, and I'm going to use a Sawzall, and I'm going to grab the blade. This is just the blade, and I'm using this block so it can't skate over this way. It's still going to mess up this edge a little bit going down. There's nothing I can do about that, but I can protect, this edge here. And this is kind of a sacrificial thing. So I just have a Sawzall kind of thing, and this is just a cheap generic one. And let's see how this goes. I'm going to try to keep it fairly straight, but it's still going to scuff up. Actually, it's not the part it's going to scuff up is actually be cutting off, so that'll be okay. Now that it's started, I could take this off and get this out of my way, I think. This is how the top of the Z-axis was, and this is about 110 millimeters high. And if we slide it down and slide the bearings out, you can see there's some bearing blocks on top of some little aluminum blocks here. And let's see if we can get these off like that. But anyway, so yeah, so these blocks are pretty tall, needlessly tall. And so what I did, and I've been doing, is cutting these down and fixing it so I can fix them down onto the plate. And I turned this to and trimmed this and tapped that out. I tapped out both of these. I cut these and ground them. And I had a little problem with this one. After I cut it off, I saw that I had a screw where I would have never put a screw myself. So I had to cut it again, and really thin too. This is only like a millimeter and a half, not even. So what I'm planning on doing, because I made these lower, now I can make these lower, and probably get rid of a little bit of weight too. You can see there's a lot of the weight from this is from these steel rails, and these are very heavy, and the bearing blocks are. But I can get rid of some of the weight and some of the height by taking out these blocks, like so. And I'm going to cut some metal plates like this, and thickness-wise, you can see that this is thinner than even the thin section of this. So I'm going to get rid of the weight from 4 of these. Will probably be like maybe a pound. So that's good. Although, like I said, most of the weight is in the steel on this, and I'm going to have to rework these to do this. But so I'm going to cut off. This is scrap metal. You can see all the holes in it. I probably could put the screws on the inside, hopefully, if I remember, and cut off little segments. And once again, I can use these pieces for templates and just use centering punches to get my locations. The top and bottom are non-critical. These don't have to be counterbored, but the bottoms do, like this. And I don't have a milling machine to do it. But anyway, these bearing blocks will go here. Actually, I can put them on this. And as far as I can tell, this thing will be about 33 millimeters shallower. You can see that the height's a lot lower. And I went from 110 millimeters down to less than 80. So that's a good change. Actually, I thought it was like 33 millimeters. Actually, yeah, that's about right, actually. And one of the decisions I made, and I will never get over this. Anyway, it's going to get worse, too, because when I was looking at this, I decided just to do the 6 millimeter. There's so many extra holes. Half of these holes don't have to be in here. This is when I reconfigured. This is the one I botched. I will never forgive myself for. Anyway, so when I redid this, I put just 2 6 millimeter screw places, because that's what holds these blocks on anyhow. And so I'm going to just put one here and one here, and that'll hold it. But this is looking a lot better than it is. And also, I'm doing this. These blocks, you can see I wrote under location like left inner top, so this one go here. So you know, these blocks a lot of times are graded for and matched to the rail. So if they get a loose rail, they use tight bearings. If they have tight bearings, they use a loose rail, and so they make up the difference like that. So I wouldn't assume that these are interchangeable. You know, even you could say that the manufacturing tolerances are much better now, but you can also say that that doesn't mean that that hand fitting and matching them wouldn't help. You know, our processes are bin too, and they're pretty small. So in this, there's, I haven't really shown this too much. Let's get a good look at this. So this part here, there's 2 angular contact bearings facing each other with the dome-shaped inner race side facing each other. And then there's a little aluminum plate with 4 little 4 millimeter screws pushing the bearings together into the socket. Interestingly, and as a note, that this bearing can slide in and out. The bottom bearing can slide, so it's not over constrained. It's only constrained by the top point. You don't want to over constrain this, because it will either bend it or do something weird. Or put some, put excess strain on the bearings. And I want to clean this up before I put it together. Right now this plate looks pretty bad. I'm going to re-drill these locations 20 millimeters down. Unfortunately, I just figured out to put in these bolts, I'll have to pre-put these bolts in before I put the screw on, and I'll have to cut off an Allen wrench. Or I could just forego them, because there's actually 4 places here. That should probably be strong enough. I have an issue where I need to mount this motor back onto the Z-axis, and so this is the ball screw, and this is a coupler. This is actually a kind of a flexible disc coupler, and so I trimmed the bracket off of here because it wouldn't work for this application. I have no other brackets. And so I need to mount this on here, and if the motor's going to be here, I need to mount this with countersunk screws, which I have, fortunately. And but how do I figure out where this thing's supposed to be? That's the question. That's the really hard question. And so what I'm doing is I'm kind of putting it like this, and I'm putting some blocks underneath the end like this, and the object is to get a square and make sure it's also square, roughly as best I can get it. And so this seems to work, and so it must be roughly square. So I've got a glue gun, and I'm going to put some glue gun glue here, and then I'm going to unscrew the motor, pull it off gently, and then I'm going to use my centering punch to mark the locations. Let's see how this works. And I'm using quite a bit here because not all of this will stick, because the aluminum can just sink away a lot of the heat. And I'm going to let this set up for a while. And I just need it not to move, along the shear plane, along this plane right here. The glue gun glue has cooled down, and so I'm going to try taking out these screws really carefully. So fortunately, I have a spare motor. Actually, I have a few spare motors. This is a centering punch. It just references the diameter, and allows you to punch. These would be good for around the house or hinges and stuff. Unfortunately, if I hit them too hard, I break the glue before I want it to. So I'm going to kind of walk back and forth between these two. Like so. Now the location's marked, I can just break this off. Unfortunately, the easiest way to drill this is just with a hand drill. And I'll just try to make it pretty straight. Fortunately, these screws aren't going in that far. So. When I'm tapping holes by hand, I usually try to give them a little countersink because I really feel that it helps the tap start straight. When you're tapping, use plenty of oil, and I'm just using regular motor oil, but I use a lot of it. Try to drill the hole as deep, a little deeper than you really need, so the chips have some place to go. Keep the tap clean. Keep the tap totally straight and perpendicular to the work surface, and just relax. And the thing is that if you're in a rush, you'll likely break the tap. And try to start it straight. I usually give it a couple of threads before I start backing off, and I try to use my arm more. With this little tap, it doesn't matter, but if you're going to be tapping all day, then it's often easier to use your arm than your fingers, unless you're using like two hands. See, this isn't actually this isn't quite as good as doing it like this, because you just are swinging your elbows. It's just a better way to tap, I think, if you're going to be hand tapping in the wild like this. And I don't want to say this out loud, but for the machine I've drilled probably 120, 130 holes, and I probably tapped at least 60 of them, and I haven't broken a tap yet. And I don't have a tapping rig of any kind. I've already marked this little bracket black on the back because I need to trim the edge of it. Well, maybe I don't need to, but I want to. It's sticking out in the breeze, so they say. 2 countersunk screws. I ground the edges, tops of these just a bit, just a minute, so I didn't have to countersink them so deep. And let's see, I hope this works. I've got a scribe, and I'm going to try to scrub a line in the bottom of this. This little notch was taken out of here as it came, and I don't like doing things like this by hand because you know, this isn't adjustable in any way. So either it fits, or I have to find 2 other places on this bracket, or at least one other place on this bracket to pull screw holes. Test fit. So as long as the ball screw turns. And slowly I'm getting this back together. This, of course, is the Z motor. Here's the coupler. Here's the ball screw. Here's the little block that holds the angular contact bearings. Here's the ball nut. And this is the Z-axis kind of slider plate. This is where I screwed up the bottom of the plate by trying to take a milling bit and bottoming out these holes. Oddly enough, I did this successfully 19 out of 20 times, and that's the only time it screwed up, and it screwed up because I hit this side and it wasn't centered. And so because I've got to connect the ball nut to this plate, and what I did was I cut a block and a shim that just fits in here, like so. And there's 2 unfortunates. One unfortunate is that you know, when you use used material, you end up with stuff like this, you know. Most people will never see this, you know, except for unless you see the video. And it still bothers me, but it's used material, and the price was right. And I kind of sanded it kind of nice to surface it. I didn't have a shim of the correct thickness, so I had to take a piece of aluminum and sand it and sand it and sand it on the belt sander after I cut it out. This little gouge here was caused because originally this plate was anodized, and the anodizing is a lot harder than aluminum. It's aluminum oxide. It's the same stuff the sanding belt's probably made out of. Anyhow, when you finally make your way through the anodizing, the aluminum is a lot softer, so you end up with little irregularities like that. So what I got to do is somehow, and I should really glue these together with some of the JB weld or something, but I've got to sneak this in here, pull this up, and put the bolts in this. I'm sorry this is so oily, but I've got some little blocks here, and this is the motor clamp. I'm just going to invert it, and I have a little template on taped onto it. Unfortunately, I must have not measured correctly, or my printer's a little bit off, but at least it's consistent. But I've got 6 locations for screw holes for this. I'm using the optical center punch, and I've used this a lot in this project. I think this is kind of a must-have. Otherwise, it's very difficult to mark the holes accurately enough. I'll go through and mark these for the 5 remaining locations. I've got the clamp on top of the support blocks, which are on top of another support block, which is on my drill press. I guess I could use 1, 2, 3 blocks, but why mess them up for something like this? And I'm just going to slide it around until it gets about where my center punch mark is. All the pilot holes are done, so now I can drill it from the top. I'm going to use a 1/2-inch drill bit and the drill press just to lightly countersink the holes just a bit. The top holes can be done with a countersink, like so. This face of this looks like it was turned on a lathe. This side looks like it was maybe fly cut or you know, milled at one time. They got a little crazy with the media blasting, and I want to sand this just a bit just to take the roughness off of it. I'm not going to do much. I don't want to change the shape, just take off some of the bead blasting effects. I'm getting ready to mount the spindle motor onto the Z-axis plate, and I've taken off the rails off the bottom, and there's alignment dowels for them, so it's pretty safe to do that. Still on the ends, I mark the ends. I don't know if you can see that, to which one's right and which one's left and which one's top and so forth. I couldn't decide where to put the clamp. I can see sometimes where I want it pretty much to the bottom, and there's other times what happens if I have a kind of a long bit and it doesn't quite fit, and so I want to move it up. Who knows, maybe even this high. So what I decided to do is put a series of holes instead of just putting one. And so these are spaced 15 millimeters apart, and which is kind of a fine adjustment on the motor. And it might be a little excessive, but it works out good with these holes inside the clamp. And actually, this clamp is massive. Anyway, so I had a little bit of a spot of bother in that if we peek under here, under my template, you can see there's holes here to mount our friends the rails, and so I had to kind of space this out so it avoids those, and it seems to work pretty good. I'm right between them here, and so I think this is going to work out pretty good. This is the one good edge on here that was done with like a milling machine, or it was ground or something. There were some center marks on my template here, and before I fasten this down, I lined it up with a square, a nice metal square, and I feel confident that these are within like 1/4 millimeter, and this is fairly centered. And the centering isn't a big deal, but the alignment is. I drilled these fasteners a little wider than I had to, so I can, you know, I can tram this when I'm done, you know, move it around a little bit. So, just a little bit. So I have 24 holes to drill and tap, which is going to keep me busy until dark probably. I drilled the holes. After I got done drilling holes, I countersunk them on both sides. The face a little bit more in the back. I don't want to go too crazy because this plate is only about 10 millimeters thick. I've been power tapping these with a cordless drill, and you have to be really careful doing this. It's really easy to break off the tap because you have a big heavy lever arm in which to break the tap off, and this isn't even a good power tapping bit. Anyway, so once again, I've got it on the lowest speed setting, and I put plenty of oil on here, clean out the shavings, and I actually put my arm against the battery to give me a little better purchase on it, and I go slow in and a little bit quicker out. You can see that my bit's a little bit bent right now. Boy, that looks ugly. Anyway, I drilled and tapped all the holes, and after I got done, I took a file and just glided it over the all the holes to make sure there was nothing high, so when I put the clamp down, it gets flush. I also did the other side where the linear rails would be. And this is interesting, because look how much it deformed this. And so when I took the file and went over it, look how much came off. So this is something to think about that I didn't think it would be that bad, but it was. I don't know if it was because I power tapped it or what have you, but some of the material flowed. Maybe my tap is getting dull or something, I don't know. But it's pretty flat now. I'm going to take both sides and give them a light sanding too, just to make them look nice. Originally for my limit switches, I had these little switch and plate combinations. This one's actually corroded. These were all taken out from various things. And so it's just 2 3mm screws on a little stainless steel plate. And there's little slots to make them adjustable, and since I changed around my axis, I want to make better plates than this to make them, adjustable, because they're actually running the wrong way for me. So, but I like the idea of this plate, and I like the slot feature. So let's do a variation on themes, and I have a little piece of scrap stainless steel, and I just kind of laid it out like this, and I took a steel square and I scribed a line here, and I used a carbide scribe for this. I don't like using carbide scribes against finding measuring tools and steel squares. Well, this is like a tool room grade and not an inspection grade, but I think it's probably like grade B minus or something. Anyway, so I laid out the little slotted screw thing. And I'm not going to cut the plates until I slot them. And I want to do this little angle feature. Just it looks nice, and it might lighten it up a little bit. And if I don't need to wait, why put it on? It's actually interesting that they got so close to the edge here. It looks like this was an afterthought. They need a little more room on them, so they just moved them to the edge. But to do this angle, I need a little protractor, and so I've got one of these little protractors, and these are kind of like just basically an old traditional machinist tool, time tested, true, and everything. And I hate this tool, I really do. So it comes in a little kit, and you get a box, and you've got 3 blades. One of them's made to do like the complementary angle, I believe, and so you get a nice fitted case and everything. And you have the tool, and the tool's got a little magnifier, which I really like. It's got a friction lock and a little gear adjuster, so you can turn it micro adjust it. This holds the blade inside the body of it. The problem with these is the way these rivets are. This thing is always in the way, and so you get the tool and you put a blade in it and put about the appropriate length, and you keep on twirling it around, desperately hoping that you're going to be able to make your angle. And in this case, for this this angle, I'm not like this. And unfortunately, of course, also the blade, this is made for thicker stuff than this, so it's kind of, they never thought that you would want to make something, this thin, as one of these plates actually. And there's 2 other things I don't like about it, and that if you lubricate it or grease it, the grease is always separating the vernier scale. The other thing I don't like about it, if we take the blade out, all the wear is on these little nubbies here. There's 2 little nubbies, 2 little contact areas for all the wear, and I would like to see a bigger surface for wear and stuff, because I don't think this might be hardened, but it might not be, and I realize that they can't have any contact in the center, but I'd still like to see. I would still like to see more, just, this doesn't even go all the way to the bottom, like I can get the probe underneath this thing, and they could have made this easily go to the bottom. I don't think that there's anything especially wrong with this Fowler version of this tool. I think they just pretty much copied an old industry standard, and unfortunately, they didn't make it better than it was. And so anyway, I'm going to use that to get the angle. I'm going to probably drill these out. I don't know if I can, the Dremel tool will help me much here. I took an automatic center punch and made marks at the approximate center punches on either end of these slots and a couple of intermediate ones. And these don't have to be perfect, after all, it's adjustable. I didn't have a drill bit that was like appropriately sized for this, so I used something a little bit bigger, and I ended up putting only 3 holes instead of 2, and now I've got to figure out some way to connect these, maybe by filing, but that's going to be tedious. I have a Dremel tool for these little breakable abrasive wheels, and I'm going to try taking out the center of these things. The problem is that the wheel is pretty big for it. Hopefully it'll wear quickly and maybe let me get in closer to the corners. I expect this to go flying as every time I use this. Also, this particular Dremel tool has an automatic speed control. I like the older ones better. The problem with this particular model is that, and it's a few years old now, it's model number 398. And the thing I don't like about this is this thing will lurch on you. The old ones would slow down. This has got automatic speed control, but unfortunately, it will lurch on you if it slows down. But it'll take itself right out of your hand. I hope they fix this in the later models. I don't recommend you buy this used. Oddly enough, I got all 4 of the slots done with only 1 emery wheel. I didn't even break them, which is unusual for these little wheels. And now I've got to clean these out, probably with a file. I have some needle files, and this one's tungsten. This is actually a chainsaw file. It's supposed to be pretty hard, so you should work with this stainless. To trim these, I'm just using a bimetal blade inside of a hacksaw and effort. And I hate using hacksaws, but the sawzall is even worse because it's difficult to control and the vibration is just crazy. And once again, one of my shop teachers said that most people, of all the tools he had in his shop, that the hacksaw is one that a lot of people cut themselves on. It's really easy. It was difficult to control the blade when it's starting. Well, you get the idea. I'm just putting a little index mark right here. And something like that. And the switch will be something like that. The spindle motor clamp is mounted on the Z-axis front plate. These are 6mm cap screws with lock washers and washers, respectively. And yeah, so I also put tape on the top here and the bottom to protect the edges. And there's a cup here, so this thing can take a bit of a hit. Maybe from this high without damaging it, perhaps. Although I believe there's a clamp in here that actually pushes the bearings inside of here. So if you really nailed this thing, it might cause damage anyhow. But this would help. You don't want to drop it on the spindle and it actually makes marks in the bearings. That's bad luck. I have some of this blue tack compatible sticky stuff, which is like chewing gum. And I've taken some of it and I've just stuck on the switch on the plate for now, and because I have some flexibility where I put this and I want to put it in the best place. I've also put some in the back here. I do have an issue though. You can see up here where I countersunk for the cap screws that it encroaches the edges. Even if it didn't encroach, it'd still be close to the edge and unsuitable for putting a screw through another screw. That's always bad luck. Anyway, but if I move just a little bit more right here, which I think I can put a screw in, I think I can, drill that accurately, then I'll be okay. So I've got this little switch plate, and what I'm going to try to do, and it's hard to do on camera, is I'm going to lower this about where I want it, like so, and it's farther out this way because of all the blue tack stuff, and figure out where it clicks. And then stick it in place and then mark my locations like that. and I still have some adjustability. And you know, I'm probably going to run a line up here to get it more accurate, but that's just about how I'm going to do it. So the cool thing about using all this stuff is you can, once you get it all lined up, you can actually test the switch. I'm going to just lower the switch until it clicks. I'm going to stick it here, and at some point I'm going to drill these out, and then after I get that drilled, I'm going to take these parallels and put them behind here, and then I'll make it nice and straight. Then I can mark the locations. But I think what I really want to do is make sure that, you know, I've got a little clearance here, and actually this is going to be walked a little bit back. My real limit switches, the terminals are bent already, so that's not a problem. Once I have the switch pretty much where I want it, I'm going to punch it using a centering punch, which is a punch that references the outside edge. And I'll just put it in here and give it a tap. And I've got to be careful because this is only stuck on here with tacky stuff, so this could move. And so what I've got to do is sight down the holes to make sure this hasn't moved appreciably, and then I'm going to drill it and tap it with 3mm screws. Because this is only thin sheet metal, about 2mm, I didn't countersink it, so it's going to be a little harder to get it started. Because this is stainless, make sure you put oil on it. And this will need some pressure to get it started. You can tell if you've done it wrong because the tap will break. And if you don't push hard enough, like I just did, then it will back out on you. Stainless is not fun to tap by hand, not at all. Oops. This will make it more exciting. You can actually feel the tap twisting. This is the correct size drill bit too, so if it snaps, I'm going to back off a little bit. Listen to the crunchy. There's a paradox that you have to back off to break the chips, but if it's not started enough, it will be bad too. Ooh, it is hard and gummy, you can feel it. That's not the sound I want to hear. I think I'm going to clean the tap. That's the drill bit that came with the tap. This might not be the best oil to use for this. This is like regular motor oil. You know, that fancy tapping stuff. But you can hear it stick. I think the chromium makes it brittle and the nickel makes it sticky, I think. That's my guess. But you know, it's funny. It's not only sticky. It's a little flexible too. It really, the only reason why I can keep on clicking is if it springs back. It's a little springy compared to steel. Well, I got away with one of them anyhow. In the vise I have a little 10mm aluminum plate, and I'm making some more Z-stops. These were the first ones. In some ways they worked good because this adjustment screw really worked good. In some ways it was bad. This didn't quite work out. Having this hole was a little too big for, and so this thing would kind of move around like this. Plus the holes were oriented this way, and which is like suboptimal. So you can see in the vise I've got the 10mm plate. I've radius drilled some holes already. I try to keep this together as much as I can until I saw it apart, and I'm just using a hacksaw. But unfortunately, you can see, or you can't see, that I'm just using magic marker for layout lines, and it doesn't last long. And I'm constantly having to touch up my my marks. I try to eliminate any layout lines which might be confusing, like that's not good, because I don't want to saw on the wrong line. But when you're making stuff by hand out of metal, this is actually kind of a pain that it's hard to keep lines that are dur. Maybe Dicom Blue is a little more durable than this because it's thicker. I don't know. I should hope so. I use just an ordinary hacksaw because the blade is under tension, so the blade could be very thin. This is only like 1 millimeter thick, this cut. Yeah. I had some holes here, and you can see that fortunately they're out of the part. So this time you could use your thumbnail to start this. I wouldn't use the fleshy part of your hand. You always have to be careful of cutting yourself in a hacksaw. If it slips off, it might cut you. So you always have to be careful. Take little strokes in the beginning and try to hold the saw straight and start off especially smooth. My whole thing's moving, but this is the Z-axis, the lead screw, the linear bearings. This is the ball nut support block. And I cleaned this and I put some polyurea grease on it. And yes, it's chemically similar to urine, I think. Oddly enough, but it's some kind of polymer. Anyway, so I have these 2 shims to put in here. And I didn't exactly know how to do it because it's not so easy working in here. So what I did is I put 2 grub screws on here, and I can put both shims on this like this. And now I could take the plate, and which is not light, and gently lower it like this. And then I can line this up like this. And when I get this lined up, sorry about the reach, I can take the grub screws and walk one of them out like this, and now it's supported. And now I can walk the other out and replace it with a bolt. I wanted the motor mount to be adjustable, so if I accommodate different router bits or milling bits, I can raise it or lower it. I also put a series of holes here so I can change where I want the depth stops, and as far as the mechanical, physical stops and the limit switches. I got this a parallel here, and this is fairly parallel to this surface here, and the motor mount itself is pretty square to this plate. This is the one good factory edge on this, and sometimes there's no, there's no replacing like a milling machine. Like these holes are not totally perfect as far as their drilling, and if I had a milling machine, this would come out better. Hey, I should make a milling machine because this is just a one-off. I haven't preloaded this cable chain, on a flat surface. And if you're running cables like this, I find that it helps to take your existing cables and wires and tie them over to one side, and then you can work on, passing the last few cables through. We're looking top down as I'm threading the chain. You can see I've got stuff pretty much pulled over to one side. I try not to make passes with the cables and stuff. When it gets very tight, forceps are your tools of choice, and you should maybe make the in this case the hose a little bit longer, and it's basically as fun as you would think it would be. Where it gets really tight, it's probably helpful to push out a little bit on one side, then pull on this side, and so forth. And when you're doing this, it'd probably be a good idea to plan for a little extra time. Here I'm using the forceps to pull these, and hypothetically, if you had enough of time, you could probably put a little soap and water on these, but you have to allow all the wires to dry out before you do anything, and a little extra time because there will form a meniscus between the 2 cables, or multiple cables, as it were. But plan for some extra time when you're doing this, and you want to save this for when you're patient, because this requires a certain amount of patience and dexterity and time. Sorry about the lighting in this shot. It's going to be impossible, but when it gets to this point, it's a lot better. But there'll probably still be some twist in these because as this figures itself out. I'm soldering this little 4-pin microphone style connector onto the motor, and that's what comes with it. Anyway, I have this is This is a 4-conductor, unfortunately unshielded wire, and I'm going to try this and see if it works. And if it works, it works. If it doesn't, I'll have to buy some wire. And so I've got a piece of heat shrink on here. I've figured out which one of these pins is ground because it's not connected to anything. I'm not sure why I'm running a ground wire to something that's not connected, but I'm not gonna run a ground wire and not have it be connected to anything. Anyway, the whole machine is grounded anyhow, but I'll look on the forums. I don't want to crack open this motor yet because it's brand new. It's under warranty. So for right now, I'm gonna risk it and just solder these up. Still, I'm trying not to psych myself out in that I'm using the green for ground on this, and the other 3 wires can be the other 3 phases respectively. And I'm just doing this whichever way it wants to go together here. And if I need to reverse it, I'll do it on the other side. When I solder wires and connectors, I try to put the connectors together. That way the heat is sunk between 2 connectors, and so there's less chances of the terminals in melting and coming apart. The combination of thick wire and high density and short leads makes this not the easiest soldering job. And if I strip too much, then I won't have this strain relief here. Well, I've decided I hate this connector. I had to solder this thing like 2.5 times. The problem is that this part is too short. So you've got to skin your wires very, very short if you want strain relief on this, and you probably do. Another alternative might be to put epoxy on it, but I'd still want strain relief underneath the epoxy. Sometimes for low voltage I use glue gun glue to mobilize things and provide a little strain relief. Because this is expensive, I'm also going to put a layer of electrical tape. As unfashionable as that is, I think it's cheap insurance. You can see how little room you have, and I really want this crimped on the outer jacket. This is like, I think like 16 gauge wire or something like that, 12 gauge, 16 gauge wire. And there's barely enough of room in this connector. You can see this thing is really tight against here. And there's not that much jacket on this. You know, this connector is just too small for this job, really. If this is 8 amps, then this is probably insufficient, I think, because of, not so much because of the pins. These pins might be able to take it, but the just the you know, what kind of jacket it can grab onto, and you need some kind of strain relief on this because this is a moving thing. Jeez, this is just not a good design. I'm sorry, but this needs a rethink. These military connectors are somewhat unusual. You've got your little plug thing, and this one the pins are integral, and the strain relief, there's no strain relief on this one other than some heat shrink tubing. And then you have a big wide connector that goes all the way down, which forces it which pulls it this way. And then you've got these little 2 half pieces. You can see this is shaped like it's a little half piece. And these go together like this. And like so. And it forms a full circle. And this little thin ring screws onto here with some encouragement. Not quite together. We're a little fiddly. Like this. Little ring goes on here and tightens that much down. And then this little ring goes over your strain relief. Actually, this is part of your strain relief. This is what the strain relief connects to. And this twists on like this. Like so. Now, of course, as you tighten up one part, the other part wants to loosen. And then there's these little parts that form the strain relief, and there's little notches in here, so it fits in like this. And then we get 2 of the screws. Hopefully, they're the same ones that assembled this at one time. I'll find out in a second. Like so. And another one for the other side going through the opposite direction. I like these connectors, oddly. I don't like reusing them because there's a C-clip, which you'll see. And we tighten this up like this. There's even a little lock washer in here just to make sure. And then this part gets screwed onto the other side. On the other side, there's like two halves of like a biscuit or a frick kind of thing with pins. And these pins appear to be silver plated. I've seen tarnish on them that are silver plated. One thing I do is from the top here, I put a little black mark that lines up to the notch, which lines up to the notch on this side. So as you put this together, you know where, in this case, where the ground is and where the notch is. Oddly enough, this is actually right. It looks wrong because there's a little rubber piece here. There's another screw-on stream leaf attachment thing. Oddly enough, this thing goes on this way, and this looks wrong, but it's not. This slides over the end, and this is unusual. And then from the back here, there's a little C-clip, which I took off, and that gets, I'm going to flatten out a little bit and put that in there. It snaps in, and then this slides up to here. Eventually I did wrestle the circlip in place, and this screws on. The other one I had didn't separate here, and this was a nice feature, and I wish I would have known about this as I was taking it apart. Now I've got to pull this back to here and connect it. I made this little board arrangement to hold the VFD, and it's just a board with a bunch of holes in it to allow a little more ventilation. I've pre-drilled locations for the VFD, put some little angle brackets on it, and so it sits like this, and that will sit like this. I have the variable frequency drive for the spindle motor mounted on this board that I prepared before, and there's plenty of air holes in this because air doesn't like to make right turns, and if I can get air coming through here as well, then that'll help. And there's a fair amount of space around this, and this interface box acts as kind of a heat dam so the hot air doesn't waft over from the other drivers. I hate this extension cord, but oddly enough, it's being used for an extension cord right now, and so I don't like it being yellow, but maybe there's something I could do about that. Originally, the shelf was mounted about this high because these holes just happen to be here, and in order to put plenty of air space for the variable frequency drive, I lowered the shelf and I re-drilled the holes and stuff. You can see the relays and stuff under here, and don't worry, this isn't energized. Right now you can see cables just kind of sitting here in this the bottom of the cart, and when I get done, that's not going to be like that, because what I'm afraid of is like what if the water leaks into the cart, and I don't want any wires to be in the water, so there'll be no wire below this point here, and so it's getting there, and right now the ground is disconnected, but I'll hook that back up. I might have to make these wires longer, and also, like the variable frequency drive needs a ground as well. So I'm testing this submersible pump and all the hoses and stuff. This is these are the hoses coming from the spindle motor. There's only one run of each, and I needed 20 feet for each on this. It's a 3x4 foot mill roughly, or like 900 millimeters by 1170 millimeters, something like that. So this is how much hose I got. This is just vinyl hose. Maybe the silicone would be better. I don't know. I thought the silicone hose would be more expensive. I don't know which one would kink less, but the hose, as I said, the hose they gave me with this kit was it's too hard. It's it's basically nylon or polyethylene tubing, and that's not going to work for me. Anyway, this is wonderfully creepy. I have no GFI on this, and I think that really I see this as evolving a great deal. So I'm going to get a GFI on this because we're playing with water and electricity, and that's a no-no. If this bucket fell over while I was standing it would be really bad. What else is wrong with this? There's no ground wire in here. That's what's wrong with that. There's no ground wire in here. Plus, you have to think that, this hose, and if you had a leak, that would be a conductor too. And probably distilled water would be safer for this too because it's less conductive.
And I noticed that it took probably like 20 seconds for this thing to prime. I can show you what it looks like. And right now I just have it hooked up to an outlet strip. And so it's not, you can hear it trickle if I'm quiet enough. And you can see if I just kind of pull this up, I'm trying to be careful. You can see. So, yeah, so that seems like it's going to be sufficient. What I want to do is get like a tank and some kind of radiator. And actually, my fingers got wet doing that. Just to point out how stupid I am at this particular moment. But in my mind, I had to make sure this worked. Now, you know, I don't want to die doing it. I'm ready to spring out of here. Actually, I don't feel so good anyhow. I've got a cold, another cold for some reason. Anyhow, and so I'm happy that this works. I guess these little minor kinks aren't doing too much. I might have to trim this at some point, but I would at least want to get this situated. And once again, hey, I think I will need a bigger reservoir. If I'm just using a reservoir, basically it's a place to move and store heat. And basically it's a heat sink. It's not even a heat sink, it's just basically a thermal mass. That's what I have now. And so this would only be good for the shortest of runs. I could probably maybe be okay in a minute. And it's not like I want to stick my hand in a bucket full of water while this is running plugged into the outlet. So this is just to test the spindle, and otherwise, I think I'm going to drill a couple holes in the bottom of the cart, so if this ever fell over, it would drain out of the cart. Maybe. I don't know. I don't know if that's safer. Well, regardless, when I'm done, there won't be any wires in the bottom of the cart. There might be accessories and stuff like that and some padding, but there'll be no wires touching the bottom, not like this. But so far this works, and it's actually, if it wasn't so dangerous, and I do mean bloody dangerous, it would be fun to play with, but you can see it's terribly dangerous. What I was trying to do is make a determination, is this pump sufficient for my needs? Should I bother wiring it in? So I'm going to chop the end of this off and put some terminals on this, and I'm going to wire it so whenever the E-switch is off, meaning whenever the unit's on, this will be going too. And yeah, I don't have a flow meter yet. That's something to think about too. But once again, it needs a GFI. Once again, you can see no ground here. I imagine this is the neutral. But it's imperative that your outlets be wired right, and not all of them are. So what's wrong with this picture? First thing that's wrong with the picture, this isn't really grounded. Second thing that's wrong with this picture is I have no GFI, and which I think I'm going to need for this part of the rig. Third thing is I've got an open bucket. It could fall over, and if it falls over, I can get electrocuted, maybe even dead. Fourth thing is that the aspect ratio of this is not so good. It's still a little taller than I thought it would be. Fourth thing that's wrong is that, you know, if I'm going to use a thermal mass without a radiator or something, I'm going to need something much bigger than this. And fourth thing is that if this was distilled water, I would have to worry about corrosion less, but also that it would be less danger if if the water got out. You know, if you have a leak, you know, if you cut a hose or something like that, this hose comes out of the bucket, and you've got conducting water and electricity. That's a deadly, if not dangerous, mix. And currently I've got these little filter things, and these are industrial things, and these are really old, but I can't see why they would fail. Anyway, there's a common mode choke in here, and there's a capacitor bridging it, and I'm thinking that the high frequencies would be bridged here. There's another the bridging capacitor on the other side. There seems to be a low resistor here to pull down the line voltage. I imagine this would be a very high resistance. There's also two other capacitors here, which like kind of do pull down kind of a differential thing to ground here, and but what this doesn't have is an MOV, and so I got these MOVs, and these are undersized, and I was just reading about these, and so basically these short circuit when the voltage gets over the rated voltage. In this case, this one's 130, this one's 150, and I have to buy bigger ones, and they should probably be like 130 volts for a 120 volt line, and just a little bit larger. So if this gets over 130 volts, it starts shorting this out. And the thing is, these don't last forever. They wear, and they can short out and start a fire. And because they short out circuit, they short circuit. And the problem with these is that these basically create a short circuit, and they can thermally run away as well. And I think I'm going to get bigger ones than this, maybe twice as big, and just to make sure. And the current that these deal with is just the current of the spike that it's basically shorting out. So they don't have to be very large. I just don't want larger than this. But for now, I'm going to track these down and install these, bridging them like this. And I'll have to keep my eye on them too. And I'm thinking, and because these do wear out, that these are going to be temporary. These are going to be very, very temporary. Then I'm going to put bigger ones in there, and then I guess I'm going to replace them on some kind of maintenance schedule. Like once a year, replace them, and for an industrial application. But I think that even though these are undersized, this will be better than nothing. When I went to my local electronics store, I found out that they also are now dipping ceramic disc capacitors in the same color. So you just can't buy a blue thing of about the right size. You got to check the voltage and make sure it is an MOV and not just a disc capacitor. So I've got a 1/4 inch US router bit mounted in this collet, and I got this pretty tight, I hope. These are tight also, I hope. Anyway, I've got a scrap of wood here, and I've got 2 clamps holding it. I can't move anywhere near here, and I've already tested this tool path about 5 times floating in air. And so what I'm going to do now is bring this down and touch off on top of this and mill. Hopefully it should go about halfway through here. And hopefully not in the board, so we'll give this a shot. So I'm moving it down. And I'm going to touch off. So I'm going to try running the program, and hopefully a bit won't go flying. I've had one issue with feeds and speeds. I'm not sure what the feeds and speeds for this should be, but we shall see. Well, routed, but my feed is too slow, and it burned the wood a little bit because my feed was too slow, but it didn't go through the table, so there was no disaster. Just a little bit of a learning curve to do, but so far I'm happy.
Well, you know, when I was setting this up, I just put this bucket of water here, and it's probably about 2 gallons, 2.5 gallons, something like that, at best. And so I figured that'd be okay just for testing and stuff. But once I got a piece of wood on the table, I noticed that, well, I lost track of it. But you can see that it's 33 degrees centigrade, and so it's warmer than bath water. I would say it's probably about 105 degrees Fahrenheit, maybe more. And so I've got to get a bigger bucket to do anything. And you know, it's one of those things. You know, I'm just testing 1 minute, and the next minute I'm having fun with it. And then if I let it run much longer, it might have overheated. What I hope to do is have this drilled at its own top, and so this is bolted down. This is a piece of tabletop. It's fairly strong and surfaced on both sides. So this would be my first kind of tool length plate, board. So I wanted to drill an array of holes. In order to do that, I've got Linux CNC. I'm using native cam, which I really not like. And however, I had originally had the number of holes wrong. It was my mistake, and I've been doing dry runs on this to having it, you know, drill down, almost touch the top, to make sure the spacing is right. And so far, it saved me from 2 mistakes. You know, I'm pretty new at this, and I'm going to make mistakes. I've got some little locations kind of penciled in here about where these should be, and the interval should be about here, at least the first interval. So I'm going to check this as it more or less fake drills. And I like, you know, testing stuff before you actually start, you know, cutting and drilling and stuff like that. So I think I have it where I want it. Let me check the bit. The bit looks pretty good. Sorry about the view. And so I think I am where I want. Still have to be careful of these bolts here, because these are a little bit proud of this. I think I've got enough of Z clearance to accommodate that, and we shall give this a shot. Once it starts, unless the bit breaks, I'll likely let this go. Well, unless it hits the rail or something. But I feel somewhat confident. So before I clean up, there's a story here, and you can see that the as far as my feed rate, the Formica liked this feed rate, and maybe it could have been a hair faster. Most of the sawdust is fairly good size. There's some powder and stuff. Maybe it could have been just a hair a bit faster in the feed rate. I have no burning in the holes, and the reason why I have no burning in the holes is because I did some test samples, and there's, you know, feed rate calculators and everything. This is kind of difficult because this is this is not a homogeneous thing. There's a very hard surface and kind of a soft inside. But overall I'm happy how it came out. What can this bit show us? So I see black. I'm not sure if I see blue. We'll find out. I've got a little Scotch-Brite compatible pad here, and let's see if this stuff comes off. If it's been exposed to too much heat, then it will be blue under here, no matter how much I do this. It looks like the drill bit survived this. I don't see blue. Once again, it looks like especially in the flutes, it looks like the the smoke and vapors condensed onto the cold drill bit, giving this pattern. Actually, this is not good. This Scotch-Brite pad is actually harder than the drill bit, so you got to go easy on it. And this is, got like aluminum oxide on it, but I don't see blue. I see black and soot and stuff like that, especially in the flutes, like I said. This is a cobalt bit. I don't recommend doing this with a tool steel bit, but so far it seemed to work okay. We're looking at the bottom of the rail here, and I was debating how much, if I really wanted to make this kind of an under rail, under gantry machine, and the fact that the rail's pretty clean, while there's a huge pile of sawdust here, actually makes me feel pretty good about things. And apparently, even with this much sawdust, it didn't get on the rail, so good. Well, that seemed to work out okay. I've got some little wing nuts here. These were actually taken off of something. I can't remember what, and then I've got to get some little bolts that are long enough and make some kind of clamps. So I've got a grid of 100mm square, hold down things. And I'm trying to make some of these little clamps, and the idea is that these can either be used with 2 bolts or 1 bolt with some blocks underneath, like traditional, milling machine clamps. And I trimmed these off with a jigsaw, and I milled the ends, and actually did pretty good. I used a 3/8" US milling bit, which is probably about 8mm, 9mm, or something like that. And it did a really nice job. I was really surprised how well it milled metal. And so what I'm doing here is that I'm slotting these. The hard part is, how do you clamp down your clamps? And so I made this kind of for-use kind of clamping arrangement, and I just have like even wooden blocks holding it. And you have to expect when you make something heckin' new like this, it could very well let go on you. And you definitely don't want to operate anything like this without hearing protection, without eye protection, maybe even a face shield. And a lot of CNC machines, you notice they have a guard in front, and so you have to be careful. And I just have this screwed down. These are really thick screws. These are 1/4 inch. I learned some things. First of all, I learned that to do slots like this is like a 6.3mm slot that's 12mm deep, so that's roughly 1/4 inch slot and a 1/2 inch piece of metal. That it's going to be really hard, if not impossible, to do something like this without some kind of way to get the chips out of the slot as you're milling it. And also what I did was I made the slot a little bit wider, and so it has to take 2 passes. But I wanted a little room for the chips, so this bit is roughly 6.3 millimeters. It's an old tungsten bit I had bought for a milling machine, and oddly enough, the old timers were really against carbide, and they liked tool steel and stuff, and so these are cobalt bits. And oddly enough, for a beginner, I think they're a decent bit for a beginner for a lot of things, because they're tough. I might have broken this bit if it was a carbide bit doing my feed and speed experiments. So anyway, I found out I really needed to get the chips out of the pocket. I'm just using drip-wise oil every now and then, and you have to understand that if I put some oil on this thing as it's being milled or routed, then the chips could clump up in the oil, and that jam could break the bit too. So there's a lot of reasons why the bit could break, and other than the feeds and speeds. For vibration, the machine seems to do fairly well, and I'm getting a lot of noise from it, but a lot of it, oddly enough, and I never would have thought about this, the table. So this is about 3/4 inch. This is about 21 millimeters of MDF capped with Formica on both sides. This is a rigid piece. I could easily stand on this, but you know what? This isn't anywhere near rigid enough for doing metal milling, I find. For wood milling, it might be okay. This whole thing resonates, as you'll hear. I'm sure my mount resonates. Wood is very musical, and it's very resonant. It's very light, and probably not the thing that you would want to mill on. So what would be better than this is even if I took a metal plate and put it on top of this, then it would have a larger mass to move. You know what I mean? This is, milling metal and plywood is definitely suboptimal, and so this is what I had, and this is what I'm running right now. So this is a vacuum cleaner I found on the side of the road, and I tried to fix up. I can't remember what was wrong with it, but there were a couple of things wrong with it. And anyway, so I disconnected the belt, and this is not a wet or dry vacuum cleaner, and I'm likely messing it up like this. And unfortunately, this one has it says reusable on it, but this looks more disposable than the other one to my eye. I think the older version of this vacuum cleaner is better, the red one. Get the red one if you're going to get one of these. So anyway, you can see all the metal chips I have in here. So this is doing its job. I've got a little, sorry about the handheld. I have a little snoogling nozzle thing. And so this seems to be working. On the table, I'm going to be milling this clamp right here. And I've got kind of a scribe line, and I'm going to mill kind of the top off of this. I just want this to be a little bit, trimmed down, so it'll fit, underneath things and stuff. And so this clamping arrangement is not wonderful. I've got some scrap blocks here. The thing I don't like is that this is on an angle and kind of a sine bar kind of situation. I do have a block on the end to keep it from kicking out, and including the block in this. And oddly enough, this arrangement is somewhat secure. Actually, look at this. And this thing will be pounding on this, thousands of times a second. And actually, the handle will be probably a better test. So this shouldn't move around messing up the handle. But anyway, you get the idea. Once again, this surface here, even 3/4 of an inch of or 20 millimeters of MDF is not enough for clamping metal down onto. So I get resonances, but I don't get as much when I'm running. I've got a 3/8 inch milling bit here, which is 6.35 millimeters, I believe. And I also 3D printed this little snoogler attachment for a vacuum cleaner. And I don't use a vacuum cleaner while milling metal, but for sawdust, this is wonderful. And this is kind of just a slight variation of somebody else's design. I think I'm going to post somebody else the other design. This is almost the same thing. I just try to redesign it so it used a little less filament, and it's got a slot in it. Maybe I'll post this design. If I do, I'll probably put a link to the other one, ask them to donate money to theirs and stuff. For me, this was like an hour and a half redesign project. It's hard to come up with your own stuff, but if you see someone else's stuff, it's easy to trace. So I'm not taking credit for this, really. Anyway, so I'll probably post a link to the original one. Also, I made this little wrench for the spindle, and this is probably as much length as you want or need. In 3D printed, this seems to work out pretty good. I put some features in here where, because the nozzle's rounded, that it's not a problem. But still, I had to do just a little filing on this because I wanted the tolerances to be tight. And if you make this loose, the tolerances, there's more slop, and there's more of or less of a purchase on the nut, and the end of the facets of the nut will want to dig in more, making it weaker. So this is kind of a tight tolerance thing. And like I said, there might be a little fitting that needs to be done. But so this only fits one, so you lift this up. The one I uploaded, it's got tightened and loosened, so it's made so if you have an inverted spindle motor and stuff, which is backwards. And the one I uploaded has a T and L, and so far this is working good for a plastic tool. And this is only like 70% fill, and so if you're putting the spindle nut much tighter than this, you're probably going to ruin it anyhow. So anyway, so I've got my 3/8" bit in here, and I'm just going to, dress off the top of this. I don't think I'm going to get everything I wanted to off of this, because, as I said, the angle is going to be too great, and I don't want this kicking out on me. Also, on the other end here, I've got a little stick. Sometimes I like using a little piece of wood under here. And in this case, because the metal digs into the wood, I'm not worried about precision on this. I just want a little room on here. There's plenty of other projects I have where precision is paramount, but this isn't one of them. These are clamps for hold downs, and that other thing is a little clearance. I got some of this misting fluid, and I'm trying to get a setup where I can spray it. I only have kind of two little tiny compressors. They're kind of compressor vacuum pumps, and I'm trying to come up with some kind of rig that I can mist with, but I'm not having a big compressor. My options are kind of limited right now. So right now I'm just using oil to give it a little lubrication, and I figure before I start each cut, I'm just going to take, using the latest of stick technology, I am going to put a little bit of oil on the bit. I have a problem with this thing that I can't find vinyl thick enough. Maybe I was wondering if I could put these up just for now, so you can see what's going on. Maybe I can tape it. This setup actually does fairly well with larger bits, and maybe my feeding speed was wrong. Right now I am using, I've got 13,500 RPM. It's like a 6.35 millimeter bit, or about 3/8 of an inch. And my I'm just jogging it around at 215 millimeters. The chips are about, actually a little fine, but I would rather have that. Well, when I do a deeper cut, let's see what happens. So what I'm going to do is I'm going to take and I'm going to touch off on the Z now. And what I want to do on the Z is I want to go down by 1 millimeter at a time. And I want to get a little bit past that. I'm now at minus at 1 millimeter. Now I'm going to put it back onto contiguous and jog off the top. So my surface finish is pretty good, and what I wanted was a little room for a washer, although I didn't get too much off of the front. Maybe I could put a little bevel on it just by sanding or something. Like I said, I don't want to get the angle too much on this, so I don't know, I don't want to have a scary setup. I've thrown together kind of a clamping kit, and I've got some cheap bolts here, and these will actually bend if you really, push it. This one's actually bent, so I've got this issue where if I use the wrong size bolt and you pull the access back, it'll bend the bolt like that. And so you have to be careful with this kind of arrangement. I don't have a T cutter, and I don't think this material is thick enough or strong enough to put a T-slot in anyhow, so I don't know what I'm going to do other than this. But this is what I had. I had an old piece of countertop that somebody threw out. I had some leftover metal, and there's not much leftover metal from when I was making the side plates for the machine. And so I cut up that into some segments and made these, and they're not perfect. Let's see, I went a little bit too far with the or the angle is not right on this one. I've dropped these once or something, or the stock once. There's even a place in here where it wasn't even finished, you know, where the milled edge wasn't even done. I don't even care. There's a nick on them. So these are clamps, and the first time that I hit one of these things with the milling bit, I feel a whole lot better about the quality of them. And here I've got some little kind of thumb screw nuts and stuff. These were from a piece of exercise equipment, I think that someone threw out. And I have some washers here, and so you just take a washer and a bolt and put this through on the bottom. And I have some little blocks here, and so you can do the kind of cantilevered thing like this. And these are just scrap blocks I've been taking off of things and collecting for this purpose.